All right, section 5.5 covers normal approximations to binomial distributions. So the normal distribution is used to approximate the binomial distribution when it would be impracticable to use the binomial distribution to find a probability. So this happens for really large samples. We might not want to use the normal distribution to find a probability. So N is the number of independent trials. P is the probability of success in a single trial. Q is 1 minus P, the probability of failure in a single trial. And we can use the normal distribution to approximate the binomial if the following are met. If N times P is greater than or equal to 5 and N times Q is greater than or equal to 5. So both of these conditions are met, then the binomial random variable is approximately normally distributed, and the mean, this is just our mean and standard deviation from a binomial distribution. So our mean is N times P, and our standard deviation is N times P times Q. So again, if N times P is greater than or equal to 5 and N times Q is greater than or equal to 5, so we need to test this first, then our random variable X will be approximately normal and the mean will be N times P. And remember, this X represents the number of successes in N independent trials of a binomial or binomial trials, right? So X is the number of successes. So our mean will be N times P and our standard deviation will be the square root of NPQ. And just to kind of show you what it looks like, so here we have a binomial distribution where P is 0.25. So if N is 4, then NP is 1 and NQ is 3. So these are not greater than or equal to 5. And when we draw the distribution, so this is just our probability distribution from the actual binomial distribution. So we use the formula for the binomial. So this would be binom.dist, and then we put in 0, right? So it looks like this. When N is 10, NP is 2.5 and NQ is 7.5. So again, these are not at least 5. And so you can see this is not normal, but it's more normal than this one. And here our N is 25, and now we see that NP and NQ are both greater than 5, and this distribution looks approximately normal. Approximately normal. So I can see this tail comes out a little further. As my N gets bigger, it becomes more and more normal. So here NP and NQ are much greater than 5 than they were here, and now this really looks normal. So the bigger that these values become these values, the more normal this distribution will look. So as N increases, the histogram will approach a normal curve. Okay, I'm not going to do this part because we don't do that. All we're going to do for this is this part. So let's go look at our very last homework problem here. And so we are on homework problem number 12. So it's asking you, a binomial experiment is given. Decide whether you can use the normal distribution to approximate the binomial distribution. And if you can, then you're going to find the mean and standard deviation. And if you cannot, you're going to say why. Okay, so basically you're going to check if NP and NQ are both greater than or equal to 5. And then if they are, your mean, and I'm not going to even do this one for you because you guys can do this on your own, then your mean will be N times P, and your standard deviation will be the square root of NPQ. And that is the end of chapter 5. So next we will be doing chapter 6 and chapter 7. So those are for unit 4. So you're now able to complete all of the homework for unit 3.